Okay, hi everybody. Welcome to today's webinar. My name is Erin. I am the operations director here at Softtree. And sorry, I was really hoping to do a live camera for the webinar, and it is giving me some errors. So I am sorry. So lots of new faces in our webinar crowd today, and I wish, yeah, I could turn on my camera to say hi. But perhaps my colleague Matt can give you at least a face for a moment. I've got with me Matthew Dickey. From Softtree. He is our training manager, and he's actually going to be doing all the heavy lifting for today's webinar presentation. Today, we're going to be focusing on an introduction to road design using RoadEng. To start, RoadEng needs some inputs. And I think, this is one of the things we haven't really stopped to really focus on when we've done one of these introductory webinars. So for today, let's start here. So RoadEng by itself is not going to be able to give you a road design. You need a few inputs. And the first of those inputs that you're going to need is an original ground surface. So here we're talking about being able to import your survey data. That can come in a wide variety of formats, whether that's LiDAR, DEM, DWG, or DXF, CSV, total station, you name it. We basically need some type of data with elevations, and that's going to go into RoadEng. That's going to help build our DTM to represent our original ground. From there, the next input, and this one can be as simple or as complicated as you would like to make it, but we kind of need to know some alignment details. Your start and end coordinates, some specifications, your design speed, any constraints that you might need to consider. You're going to need to know that. And then lastly, you're going to need to know kind of what your cross section looks like, whether that's a very simple trapezoidal prism with a specific width and ditches and some slopes to it, or perhaps it's much more complicated. So we're going to have those sort of three core inputs that are going to go into RoadEng in order to allow you to do a project. There are a bunch of things that we're not going to talk about today that you could also input into the software. And these additional inputs can add a lot of realism and really improve the quality of your design. So if you have additional spatial constraints or additional data, we can bring that in. And then more on the sort of materials side of things, we can tell the software as well as an input what materials are in the ground, so what's available to be used, what of those materials are to be wasted. You can then tell the software as well in your cross-section which materials need to make up which different parts of your typical cross-section, the material costs, as well as how you want to handle those materials, if you need to borrow them from somewhere, or if you need to waste them. There's a lot of other inputs that we can bring into RoadEng to help out realism. So again, focusing today in this introductory webinar on the left-hand side of the screen. And from there, we're going to be able to get sort of a road design project. And those outputs that can come from it, our 3D road model and geometry. We can get our material volumes. If we're working with more than one material, we can get material volumes by specific material. Of course, you're going to get an earthwork movement schedule telling you how this material is being moved to construct your project. And then, of course, there's the documentation and the digital output side of things. So this is, kind of a look at what we're going to be doing today. We're going to break it down into three pieces. The first is going to be focusing on that TOPO data import, building of the terrain model. We're also going to include a little bit of Path Explorer in here to help us figure out where to put an initial alignment. The second section is all going to be about that sort of core road geometry, the cross-section template. How do we create our horizontal alignment? How do we add curves, the vertical profile? And then finally, in our third section, we're going to talk a little bit about refinement and output. Now, if you are new to our webinars, I should say you are muted. You can ask questions throughout the webinar. We do tend to tackle them at the end in a Q&A section. All question askers do remain anonymous. If you are watching this webinar off YouTube in the future, please type your questions in the comment section. We're happy to handle them. And then lastly, our webinars are not really follow along live webinars. They tend to be more like, hey, here's a presentation of the content, and then you can go back and look at it later. But today, not only is it going to, continue to be just a presentation of the content, but afterwards, we're actually going to give everyone access to the training files that we're using. So if you want to go back and practice it, and we've decided to use the data sets that we've actually made our full online e-course with. So if you would like to go in and explore any of these topics, as well as some additional ones, you can do so. We're going to give you the code to get you free access to the e-course at the end of this to let you actually go and keep learning with it. So that's a little bit for my intro. Let's get into our first section here with one additional slide disclaimer, which is we talk about RoadEng, obviously heavy focus on roads, which I've got some different examples here on the screen of, but this can apply as well to any type of corridor project. We're talking about just adjusting our typical cross section. So these fundamentals, whether you're working on a pipeline, a run-of-river project, a rail project, a lot of the fundamentals of how you set the project up and that alignment, editing, and design very much consistent. So, and this is going to apply pretty much to any project you're doing in RoadEng. Okay, section 1, topo and terrain. And this is also important to note. The terrain module is one of 2 modules in RoadEng. So you're going to see us in this first section play in the terrain module, and in the second 2 parts of the webinar, we are going to be in RoadEng's location module. Okay, survey data import. We are going to start by bringing in some LiDAR data. Now, I did mention it before, we work with a wide variety of survey data. You just basically need elevation points with your data to be able to create our tin surface. But it is important to know, especially if you're new to the software, that RoadEng itself does not discriminate against good data and bad data. And of course, not all survey data is created equal. So it is an engineering decision for what type of data you are comfortable using and for what stage of design. But if you are working with, say, 50-meter data from an SRTM, that data quality is not going to be nearly as good as something that was, say, perhaps collected with LiDAR, and we've got a much, much tighter point spacing. So the data that goes into RoadEng is going to be the basis for all of our earthwork calculations, all of our details that come out of it. So just making sure, step 1, you're comfortable with what you're working with from a survey side. A couple other fun notes, because I don't know if Matt's going to cover them, but survey data often can come in georeferenced. If you've got, for example, conventional data, if you have the opportunity to include that georeferencing, so this is kind of tying it into a known coordinate system, it's going to give you access to a whole bunch of cool tools in the software, whether that's bringing in a background image through our live maps, exporting it out to Google Earth, exporting it through to Avenza, lots of cool functionality that comes when your data is georeferenced. So make sure you do that if you can. And then lastly, again, a topic we're not going to cover, but the LiDAR, UAV, and DEM data that we love and keep seeing more of, it can have a huge point count to it. I've seen data sets that are 200-300 million points. Well, that's not feasible when you're working with a design software that is constantly creating and modifying surfaces. So we do recommend trying to get your point count down to about 10 million maximum. Of course, if you're running a fancy computer, that number goes a little bit higher, but being aware of that and then leveraging thinning tools and strategies if you do have large data in order to keep that point count and that file size a little bit more manageable. Okay, so that's kind of part 1 of topo and terrain. The next part, we're going to take that survey data. Basically, all the little points that are there, they get connected when you go and to build a tin surface or a DTM. And the couple note points here, but contours, when you do add them, they are mostly a visual aid. They add draw time. Sorry, there's a nice look at it of what that surface could look like as just a mesh. But yeah, that 3D surface is what we work with in order to have the basis for our original ground in our design. And then lastly, we're going to talk about this one too, but this is a little extra. It also just happens to be my favorite feature in the software, which is Path Explorer. So Path Explorer, if you're doing greenfield project, can save you a fair bit of time solving that problem of where should I put my road on the landscape. Narrows it in, gives you some options. You can then validate those through a much more effective use of your field time. And the solutions with Path Explorer can account for things like your minimum, maximum grade, horizontal curvature, hydrology, some geotechnical conditions if you know your zones of higher cost. And it can be really, really awesome way to kickstart your road design process.
All right, cool. So I'll run with that and start right from scratch, kind of as we usually do here, and start out in terrain. So I'm going to just insert file, and to start, I'm going to bring in my LiDAR data. And usually the LiDAR data is going to be georeferenced, in which case the software would read the projection tag to it. In this case, it doesn't have a projection, but I tag to it, but I do know what it is, so we can just assign it here. And away we go. Now we brought in our 4 tiles. We can turn those points. So the big magenta blob is showing me all in this case, 2.6 million points. To turn those points into a surface, we'll click terrain modeling, generate, and we will create our surface and our contours at the same time. And we can click on the 3D view and see exactly what it is that we're dealing with here. Now for this, so if we were just working with LiDAR data, great, we have our surface, we could run with that, we could do our design with that. But if we had something that was other than, say, LiDAR data or DEM data, we could work with that too. So kind of as an alternative workflow here, we can, let's just tile this side by side. I'll open up another instance. So instead of doing what we just did with the LiDAR, we could, oops. Dump in our conventional survey data. Now with this, I've got my conventional survey data, so this being collected with an RTK GPS in a CSV, we can click open. And here I can see my import options for this. Now with this, I could use my ASCII text option, or if we've already set up our import options, we could read it in and really streamline the process. So I'm just going to merge in an IOP, and we'll open that guy up. And what this does is, and previously, and we could save it as our default so we didn't have to read it in each time. But previously, I've told that anything that was shot as a CL is going to be a red line with triangles at each point. My EG is going to be a gray line with a circle and a cross. It's going to be treated as a break line. My ground shots, or G, are just going to be points. We can automate how that gets brought in and have it so it automatically plays connect the dots for us, and away we go. Now, that's really the big difference between this versus that. We are not just bringing in points, we're bringing in points that we'd like to treat as lines and have them modeled as break lines. But once it's in and once our break lines are connected, we click generate and we can create our surface. And here I'm going to just reduce that maximum side length a bit. And that is going to keep my triangle edges from interpolating any further than I'd like. So I've got it set so they're not, my triangle edges are no longer than 50 meters, and we can see the surface that we are running with.
And Matt, I'm going to stop you for a second. We're actually going to do a question mid-webinar because I think it's quite relevant. So this question says, are the surface, DTM, and the contours separate entities? Yeah, and are the contours cosmetic? I feel like it's a worthy one to answer mid-webinar.
Totally. So it is totally separate. So, well, I guess not totally. The contours are derived from the surface, but you can have a surface without contours. So, and there, I've just deleted them. We can see we still have that surface. So the contours are more of a convenience item. They're just a graphic to let us see what's there, but we're not stuck deriving the surface geometry from the lines that we're seeing. So here we can zoom in, we see that there's all sorts of undulations and whatnot between the contours that we have. So good question. Yeah. And I guess with that, and kind of to put a bow on working with both of these data sets, so we've got our LiDAR data set, we've got our conventional survey data set. We could work with either of these independently, but we can also combine them. And so here, if I want to combine them, I'm going to just save my conventional survey terrain file, and I'm going to place it in my LiDAR surface. And for this, we could just dump it in, but we probably are going to be a little more comfortable with the points that were actually measured by the surveyor, and we're going to have better details on things like our ditch line and what have you. So I'm going to do a merge, and we'll merge that conventional terrain file. And we could just leave the default settings here. I'm not going to include a break line on the boundary to help kind of smooth out that surface between the two. We'll hit OK. We'll hit OK. And there we are. Now we'll rerun that ting calculation so we can get our contours back, update our surface. And we're set. So we've got kind of both types of data in one file now. And that's not necessarily a requirement for most folks' workflow. A lot of the time they'll either be working with just LiDAR data or just conventional survey data, but you certainly can combine both if you'd like. So I guess we've got our surface, we've made our surface from two different data sets. We can use that surface, and we can use that surface for analysis. So one thing that's going to be quite common, and in the conventional survey data, we can see we've already have where our streams are surveyed. But on this LiDAR surface, we don't have lines showing that. So we could go up to terrain modeling, we could click hydrology tools, and we could say, well, let's let the software help us predict where those streams are. We'll hit OK. Let that guy think. And there we are. We can see all of our stream vectors coming down. We've got polygons where we expect there to be ponding, and we're set. And then lastly, and kind of to help us kind of segue towards where we're going next, well, if our main interest is in how do I get a road from, say, let's go from here. I'm going to just call this A to B. If I'm interested in going from here up to, I don't know, let's say there, well, we could, and I guess probably should before we click the easy button. Well, how would we go from there to there? Well, if I was doing this manually and hadn't seen the data set before, my knee-jerk reaction would probably be coming off here, crossing this, switch backing up, try to get on this bench or this terrace as quickly as I can and get to it that way. So we'll keep that in mind, and I'll let folks make their best guess. But of course, a big tool that we have is Path Explorer. So here, rather than going through that iterative process and kind of manually deciding where we want the road to go, which we will cover next, but we'll take the optimization tab. So we've drawn in a feature from point A to point B, optimization, Path Explorer AI, we have that feature selected. We can put in things like our maximum grade, we can put our minimum curve radius, anything else that we'd like to consider here. The software is going to consider our earthworks, trying to minimize our cuts and fills and costs associated with that. But if there's other costs or costs that deviate from the default values here, we could add construction zones to help account for that too. And just say, well, all those streamlines that we've added in, we probably want to add a cost to those. And we're going to say it's $3,000 a pop. So this is going to be a resource road. And yeah, just dealing with our culverts. We could split them out if bigger streams existed, but we'll use a blanket value for this. And we'll let it run, and the software is going to think for a little bit here, and I suspect this one's probably going to take a minute and a half or 2 minutes or so. But it's going to well, look for a solution up the hill for us. And actually, I'm going to pause here just a second. There's one thing that I forgot to do that I meant to do. And for this, I want my road to start out pointed in that way. I don't want to have it pointed that way. So if I want to add that constraint in here, we can also add that constraint in for us to help guide it. And we could say, well, at the other end, we want to come in from a certain direction, but here I'm only really concerned with it at that end. So we will let it go. It's going to think for, again, probably a minute and a half or so, and we'll see where it wants to put the road.
Awesome. And while that's happening, Matt, do you mind drawing some attention to where folks on the call can get the point count? I know I mentioned being aware of how many points you've got modeled in your project, but yeah, maybe we can take a moment to just chat through that a little bit more while we let the paint dry here with the Path Explorer.
Absolutely. All right, so yeah, Aaron mentioned it. Usually we recommend folks try to keep their number of modeled points to be less than 10 million, and that's a pretty conservative recommendation. It'll depend on computer specs, but down here is where you can see the number of points. So I've got the number of features. I've got just shy of 10,000 features, and I've got just shy of 3 million points in my file. Yeah. So if that was saying 30 million or something like that when I brought it in, well, then I'd probably want to do some thinning. And here our Path Explorer, I'll just hit cancel. It's saying it's unlikely to improve, so we can hit cancel to stop the run, and there we are. So not the route that I would have gravitated towards. Instead, this one is, well, crossing a little lower and coming up that draw just off to the side, staying out of the creek, but coming up to get to where it makes sense to be. So I'll hit save here, and then I'll pass it back to Aaron.
Awesome. Thank you, Matt. Okay. So that was the first part of the sort of core road design workflow. We set up our topo surface, and then we did that added extra step of figuring out, that potential initial alignment location. As you're going to see in this next section, we could just have set up that topo surface and we could do the process manually. So here, we're going to now move into the location module of RoadEng. So again, started in terrain, now moving into the second module. And one of the very first steps that we need to do is tell the software, hey, this is the cross section. This is what my typical section is going to look like. Now, of course, this one can be simple or complicated. We could define our road width, we could define our slopes and just leave it at that. You've got a road width and ditching, but you can also get a lot more complicated, adding in all the different elements that you might have in your typical section. And it's really important to know that these cross-section templates are essentially like mini programs. They adjust depending on the conditions they're in. For example, if you're in typical cut, it's going to behave one way. If you're in, sloping right, sloping left, or in fill situations. And this little visual up here, this is called our template editor, and it's basically a sandbox that lets you iterate and check out your cross-section template. There are a lot of different components that you can leverage. We don't expect you to write the many programs that define these, although I know we have some users that do. But there's an e-library. Grab the components you want, and the order of those components does matter when it comes to cross sections. And this is my big disclaimer now. We could spend an entire webinar talking about cross-section templates. So we're going to keep it on the simple side today. If you want to learn more, a whole bunch of awesome webinar content up on our YouTube channel on cross sections. So that's part one of our 3D road design. The next one is now actually getting in and giving it a proper horizontal alignment. And there's two different ways you can do that. You can do it the manual way. You can click in and edit the IPs, create your alignment, add curves to it, or you could leverage something like an initial feature. So this initial feature potentially could be coming from a P-line, could be coming out of the survey map module. I saw a question about that in the chat. Yes, it still exists. So you could come in with a P-line feature. You could come in with GPS points or Path Explorer, and we can leverage that. Use a tool called Polyline to alignment on it, turn it into horizontal alignment, and start to really work on the actual details of our design. Sort of two different methodologies, and they can be intermixed. You could hand and manually adjust that initial alignment feature as well. So there's horizontal alignment design, and then the other part we're going to cover here is the vertical alignment design. And this one I feel like is best explained with a little chart. So we're going to start with our ground. That is the profile view of the topo surface we've created. Very much like the horizontal alignment, we can manually click in our vertical alignment. Here you can see the grades coming along with it. We can get those in as well as you can add the vertical curves. Or we're a big fan of easiness and optimizing things, or you could use the vertical optimization tool. And what this does, this uses a whole bunch of fancy math to figure out your profile for you. It takes control points, your road specifications, your grades, your K values, all that kind of important information, and it figures out the best way to have the profile for your road to minimize the earthwork costs. And that's how much we're cutting and filling, as well as how much we are moving in order to construct the road. And all those little differences, which obviously this is a terrible example because they're huge differences, but usually little differences add up. 10 to 30% of your subgrade construction costs can usually be reduced through this tool. So that is a brief introduction to the sort of three key steps, three key parts we're going to talk about for the 3D road design. And with that, we're going back to Matt.
All right, I'll share my screen again. All right, so we've got our solution from last time. I'm going to just minimize this. And we'll close this other one. We're going to switch over to location. And now for this, I think if I used this example, well, it would be pretty easy to just say, oh, follow the line. So instead of using this exact file to start here, we're going to do that manual design workflow where usually if we're doing a manual design workflow, we won't have the Path Explorer solution. So we're going to kind of start blind and click around. So I'm opening up location, which is the other module here. We're going to click the little green icon. We're going to click new file, and I'm going to select my train file. And here I don't have an initial feature to use. Again, we're pretending as though I hadn't run Path Explorer. And we can zoom out and see what we're dealing with. So this is my plan view. I can see my cross-section view over here. I've got a data table over here. We could move things around. I want to start my road there. I could move my windows around and get them exactly how I'd like. Now, again, the software is flexible and easy to configure and use those settings again and again. So rather than moving everything around here, I have my own preference for where windows are and the way things look. So for that, I can click View, and I can retrieve a screen layout. So I've got a screen layout again that I usually use. And if I had had that saved as my normal in the default directory, it would be what appears when I start the software. But here again, so still the plan view, still the section view. I've got my profile here, my 3D view, and I've got my panels on the right open. So I'm going to just move my initial alignment over here. I'm going to, well, we could change our cross-section geometry, so let's tweak that. We'll go to our templates. So here I'm going to just do a gravel road. We can look at our template editor. So we've got our 3 defaults. The template itself, we click properties, we can see we can set our crown, but the majority of the geometry is set at the component level. So if I wanted to change my road width here, I could. Now, if I wanted a 4 meter wide road instead of a 6, I could change width on one side. Here, I'm happy with those default settings. The only thing I'd like to change here is I'd like to have a V ditch instead of a U ditch. I'm going to just change my ditch bottom width to be 0, and we'll do the same on the other side. So easy to make changes. We can have different templates assigned to different station ranges, but we'll run with this for the whole shooting match there. And we can see the ditch has updated. Now, I want to start figuring out where to put my road. I'm going to, in my plan view, have Add Edit Tool selected. I'll just click along here. So I can see starting to add a road. In here, I'm going to cross that creek. Now I'm going to hit zoom to extent so we can see it in the profile as well. But we can come along and we can see we're starting to scream up the hill. So it's all interactive. Now at this point, I probably want to set myself up to have a bit of a switchback. And here, well, I'm reasonably steep. So on this view, I've got it set up so my vertical is scaled by a factor of 10. So it's not as steep as it looks, but it still is pretty steep. We could start clicking in our vertical as well. So I can see my grades being reported. And here, if I want to keep it less than 18, well, I'm at 22. Let's pull that out. Still pretty high. Let's pull this endpoint down the hill a little bit. There we go. There we go. We'll start kind of wrapping around that slope. And we're probably at that point where our curves might start to matter. So I'm going to go over to the right. I can add in my curves. So at this point, let's try to keep it below or above 35 meter radius curve. Oh, it's telling me it doesn't fit. We'll pull this guy down a little bit, make a little room. There we are. We'll bump that back up. And we could say, well, this next point, yeah, I probably should come into the hill a little bit more there. We'll hit apply. We'll hit next. So we can work our way up. Again, keeping an eye on those grades and getting to where we'd like to be. Now, I'll go a little further here. Again, still climbing up. And I think it was around there that I wanted to wrap things up. So again, I can just keep iterating between the views, making adjustments as needed. Now I've got a pretty nasty fill there. I'm going to crank this guy up, put it into the slope. And then for all the remaining IPs, or horizontal curves, we could go through and we could add them individually, or we can cheat. And I'm going to cheat. So I know I want to apply our default curve. I want to just keep the ones I've already assigned. Everything else gets added in, and there we are. So we can see we're making our way up the hill. Our vertical behaves very similarly. So we can add in our vertical curves. Sure, we'll go with that. We'll go with that. And we'll go with that. And there we are. So we've got an alignment that's been done by hand. And obviously we probably spend a little bit more time poking around and refining it. But other than doing it by hand, well, we took the time to run Path Explorer. Let's see how that works for us. Now, if we wanted to, for a side-by-side comparison, we could add in the Path Explorer alignment here and run through in the same file that we've been working on. Actually, in here, I'm going to just save my screen layout so I don't have to assign that next time. But instead, we're going to just go back in time and pretend that we haven't clicked something in already, and we're picking up the workflow from having just run Path Explorer. So opening up a new instance of location. So in here, same exercise, just going to bring in our file, this one being the one that I ran live here. So the TOPO combined. Instead of just starting with a single point, we're going to use one of those Path Explorer solutions. So we can see our Path Explorer solutions. One of the settings that I had set was give me 5 options. So we've got 5 Path Explorer solutions and they're ranked. So this number that comes afterwards is the expected cost based off the cost I'd given it. And there we are. And this time, since I had saved that screen layout as my normal, when I start the software on a new project, it appears the way I'd like it to appear. So we can see we're going up the hill, we're adhering to our max grades. Our cross-section geometry, now again, I could have saved this too, so it appears the same way. I didn't, so give us that apples to apples comparison. We'll set our ditch to be a V-ditch. And then we're going to turn this into a kind of a more advanced design. So instead of going through and adding our horizontal curves manually, well, we can take this polyline and we can say, well, let's run polyline to alignment on it. So I'm going to say minimum curve radius 35, give it a tolerance to straighten things out a little bit, and we'll let it go. So it's thinking, it's, well, going to keep improving. I'm going to hit cancel, kind of being lazy here, but we can see we're adhering to our curves. We don't have a polyline anymore. We've got proper curvature assigned at each point. So, and here a 111 meter radius curve fits better than the default. So it's not just assigning the minimum. And there we are. So we've got our horizontal going up the hill. Now, of course, we could do, again, click in our vertical by hand. But if we're using the fancy stuff for our Path Explorer solution, we might as well use the fancy stuff for our vertical. I'm going to set up a vertical optimization. So here I'm going to say, well, let's have those max grades at whatever we have assigned. We're going to add any control points where we want to have control points. So spots where we want our road to be at a specific elevation. And we could add extra information, pits, constraints like full bench, minimum embankment height, etc. But here I'm just going to click process and we'll run this through with, without adding extras. So this is going to, go ahead.
I was going to say, it's important to note. So the vertical optimizer is looking at this whole idea of material costs, how much it costs to excavate, how much it costs to embank, and those movement costs. But even without actually going in and looking at those details, as long as the relationship between those costs, which I'll get Matt to show here in a second, is roughly directional, the road with the least amount of earthworks is going to be the cheapest road. So yeah, we end up talking in some of our more advanced webinars, especially about optimal, about that costing side of things in a lot of detail. But yeah, it is important to know it's something you can totally use even without that level of detail to get you a really great starting point for your vertical alignment to then start refining it. Sorry, Matt.
And no problem. So yeah, and with that, so this is saying that the cost, the earthworks cost of this road is at 57,000. So what's driving that is my ground types, and I've only got well, just my default subhorizon set. So I'm assuming it's all overburden at this case. And my overburden cost is set at 12 bucks a cubic meter. Embankment cost set at 4 bucks a cubic meter. I've got my haul cost incorporated in here as well. So if it's just being moved to short distance, it's going to be tracked as free haul, longer distance overhaul, longer than that end haul. And these are all configurable, but that's driving the optimization and driving the design time costing functionality. And if we compare that solution to this one that I've clicked in, and we will have to click recost here to see the difference. But there we are. I'm quite a bit more, but we'll look at the actual volumes here in a bit, and I'll pass it back to Erin.
Okay, section 3 is really all about tools that you can use to refine your design as well as output. So here, one of the most important tools, most important visuals we tend to look at is really sort of on that earthwork volume side of things. We've got a whole bunch of ways to look at our earthwork volumes. That includes the mass haul, as well as data tables, and being able to go and iterate and look at the impact that that's having and some design changes with that mass haul. Very, very important. It is a tip here, as Matt just kind of showed you a little glimpse under the hood of what you can add in to make your model more interesting, to add that more realism. So we do have the ability inside of RoadEng to define your subhorizons, so the different material layers that are available in your topo, in your ground surface, or in your original ground, I should say. We can define them, through a few different methods. We're not covering that today, but yeah, definitely when possible, adding that in, as well as defining borrow waste pits, defining your shrink and swell factors. Nice little typo of mine there on the PowerPoint to show shrink/swell factors, not factors. Can you tell we made this just before the presentation? And then lastly, one big piece here when it comes to earthwork volumes is the concept of report points. So inside of RoadEng, we tell the software through report points where we want it to calculate the volumes. These are the different cross-sectional areas that are going to be calculated. And you can have really, really tight report point frequency. You can have really coarse report point frequency, and it really depends on the complexity of your terrain. So we can use that in order to tell the software how often we want it to be calculated. So something to pay attention to. I'll ask that Matt maybe quickly touches on that one when we get back into this next section. The other piece here too, in that sort of refinement and design, obviously water is so important when it comes to roads, and being able to minimize that interception and the redirection and the accumulation of water as you add a road into the landscape. So drainage structures become very important. So here we can also go in, account for some of those drainage structures, adding culverts through the panel. Of course, tip, add those streams and ponds, that line work from your terrain, make sure that's showing up here in your location module. And then my other tip here is stay tuned for version 12. We're actually embedding all of the hydrology tools live into the location module so that when you do your road design, you can rerun your streams and ponds tool and start to better understand the impact that your road is having on adjusting those natural drainage patterns. So we're going to talk a little bit about the sort of culvert side of things here and hydrology impact. And then lastly is output. And output, I feel like it's always like, oh, and you can do output multi-plot. We tuck it in at the end of the webinars, but it's so important. Without proper output and proper communication of your design, all the hard work that you have put into your road design literally means nothing. So a design is absolutely nothing if it's not communicated properly, and making sure that you choose the correct communication format or multiple communication formats, really important. And then finally, as you can see here on the screen, for those of you new to RoadEng, we call our construction documentation editor, it's called Multiplot. And it's like most of the software, super reusable. So once you figure out what works for you, like Matt's screen layout, he's saved it and then he can call it and reuse it. We can literally do the same thing with multi-plots. So you can save your formats, you can call them, reuse them, and then start to get a whole bunch of design efficiencies by leveraging these templates, these defaults that you've set up. And with that, like every webinar that we do, we are going to be over time as I pass it back to Matt for the third section of the webinar, last live demonstration, and then we'll head into some Q&A. Matt, over to you.
All right, and there we are. So, and yeah, I guess with this, we have two designs now. So this one's the one that's done by hand, that's more expensive, versus the one that I've optimized, which is much cheaper. So yeah, we've kind of forked things. Now, if I was just running with the optimized workflow, I wouldn't, when it comes time to refine my design, it's optimized. So in the sense of our earthworks are as little as they can be. So for that reason, I'm going to use the one that's not optimized. So if I'm refining my design and I make it to say this point, and I start to kind of look at things closer, doing that by hand workflow, well, I'd start to pay attention to my volumes. So I've got a data table over here that's tracking my earthworks quantities. So my total cut and fill, I'm looking at 12,600 cubes for my cut, 12,600 cubes for my fill. I've got this mass haul diagram here, which is showing me my surplus and deficits, and I can see that I'm balanced. And yeah, for kind of adding a little bit of weight behind that comparison. This one that I just said costs more, well, the reason it costs more is instead of moving 12,000 cubes, I'm moving 3,462. So there's a substantial difference in how much dirt I have to move for this one compared to the other. Now, with this, you may also have picked up on the fact that it's balanced, this one that I've done by hand. So when I was clicking around and moving my alignment, I wasn't just looking at my geometry, I was also keeping track of my mass haul diagram. So as you're refining your design, if you're not using the optimization tools, it's still nice and dynamic. You can adjust things. So here I've lifted that one IP. We can see we're no longer balancing. I'd end up with a deficit of 5,000 cubes if I built it that way. So as you're refining, this whole aspect of things being interactive is super important. Now, also with the volumes, and whether you're considering them from the optimization lens or just trying to manually chip away at it to get less and less, where those volumes are coming from, as Aaron said, we have our cross sections being calculated, and those cross sections are being calculated at report points. So I have a bunch of report points. Some of these are calculated automatically by the software, like where I'm starting a curve, we need to have a section there. So one, models well, but two, it helps us get a reasonable accuracy for our all the volume estimates. We need a reasonable density of sections to have a good estimate. And then in here, aside from just things like start a curve, where I've changed templates, I'm telling it to automatically calculate my report points, in this case, 10-meter intervals. So you can change that if you want to be a little tighter, you can crank that down. If you're dealing with something fairly straight on benign terrain, maybe you can bump it up a little more. So that's, I guess, a high-level view on where the volumes are coming from and going to. This data table that we have is totally configurable. So it was saved with my screen layout, but I have it showing my L station. So my station cut fill volumes, we could add in more information here if we wanted. I have it reporting every 200 meters. Great. And then if we decide we want to, say, add in a culvert, I'm going to just click here. I could add in that culvert with my culvert panel. I can click add, and there we are. Now here, that's a pretty steep pipe. If we want to hang that instead, we could say, well, I want to have that at a specific gradient. And if we wanted to change the diameter of that, we could maybe go with a 1200 there. And there we are. And if we wanted to have a data table that tracked, well, volumes for one, and then maybe another data table to track our culverts that we've installed, well, we could set one up to do that. So I'll come over here. I'm not interested in reporting every report point. I'm only interested in reporting anywhere that we've added in a culvert. And the information that I'm interested in seeing, well, I want to see the station that the culvert's been added in. And then I also want to see my culvert diameter and culvert length. And there we are. So we can quickly set up a data table, and we could have these both showing simultaneously, or we could just flash this open when we were interested in how many we've added. So if we wanted to add in another one, say here, we could just throw it in and it updates. And obviously this one we'll want to have even bigger. Maybe we'll go with a 1500. So we've got culverts added in. We've got the tools to consider how much dirt we have to move in order to build what we're building. And then, well, if we want to actually put pen to paper and put this model into a document, we can open up Multiplot. Now here we could totally build out a document entirely from scratch, adding in our various views. But if you're just starting from scratch, probably the easiest thing to do is use something that already exists. So I'm going to select my page size. I'm interested in having a size D plan over profile. So I've gone onto the Access Web Library. We can see that plan view, profile view. We can make any tweaks that we want to. So here I'm not interested in having all this information at the bottom. I want my mass haul, that's it. Great. And we'll set this to only take up that much room. Now here, if I wanted to change my vertical scale, we could change the vertical scale so it's not quite as intimidating looking. And we've got our plan over profile. We also probably want to have cross sections. So same thing, we could add in a cross section chapter. And here I probably want to have my sections more free, well, fewer on a page, but also more of them. So we can set that up, and ta-da, we've got our section stepping through the geometry, and away we go. And like our screen layout, like the templates, if we had this document that we've put together, maybe we changed logos, added notes, we kind of made it our own in terms of formatting, and we wanted to use that over and over again, we could hit Save Book Layout, save it, and we can use that on our next project. So we've got this design, we've got a document, and lastly, if we want to have some kind of digital export to preserve the model or share with surveyors to lay it out, or the builder to build it, we can file save as and change the extension to all the common formats that we might want to. So land XML is going to be a nice one to preserve the model as a proper model. If we wanted to stake to point rather than stake to line, we could export the coordinates file. If we wanted to share with the GIS folks, we could save it as a shape, etc. So pretty easy to get that out in a variety of different formats. And with that, I'll pass it back to Erin.
Awesome. Thanks, Matt. Okay. We just covered a lot of content, and I know this was an introduction webinar. So what I'd love to do now is just share a little bit of things that you can do to kind of continue this learning journey. First and foremost, every section that we talked about in our webinar today, from importing topo data, initial alignment design, hydrology tools, multi-plot, all those little elements, we literally have a webinar that goes in depth on every single topic. So if you'd like to learn more and you don't want to say lean into what I'm going to talk about next here, certainly check out our YouTube channel. So many videos, we go in depth on pretty much all of the topics. But this is the fun one. If you would like to learn more, we have this exact example actually is built out as a training course, a really great interactive training course, combination of videos, tutorials that you can go through on your own, basically teaching you all the core functions of RoadEng that we talked about today, plus the ones I've got up here on the screen. Yeah, typically people pay for this. But for our webinar audience, and because we are coming out with a new version in the next little while, we are going to make this one available to you guys if you want to try it. So you can go to softtree.thinkific.com. That is our learning portal. And this particular course can be made completely free with the promo code or the coupon code of webinar 26. So really, our goal here, help you guys learn a little bit more about the different tools and elements inside of RoadEng, help you get more comfortable with the software, and then realize how easy it is to then take that workflow, put it on your own project, and start making meaningful work in a pretty short time span. My goodness, the words. Okay, we're over time, but let's tackle some questions. So a friendly reminder to our webinar audience, if you have a question, there is a Q&A section. If you go to webinar panel, you can open it up, type in anything. We love questions, makes things fun, so feel free to add something there. We are not going to announce your name, so don't worry. You can literally ask anything. There's no such thing as a bad question. Okay, Matt, are you ready for your first question?
I guess so, yeah.
How can I thin the amount of points in my survey data? With that, I'm going to give you the screen back.
Yeah, I can
make this a little bit more interactive.
All right, so we've got our file here. Actually, I'll do it right from a fresh file. It'll be easier to follow. All right, so I'm going to back to the start, file, open terrain, file, insert, and I'm grabbing my LiDAR data. So just, yeah, it's usually only thin remote sense data, whether it's DEM or LAS data or LAZ data. So I'm going to bring this in, and we'll bring in just our ground points. We could thin it on import. So if I had a feature like a polygon, we could say, well, I only want to bring in information within my polygon. Now I haven't drawn one in or entered one in there. So instead of doing it on import here, I'm going to bring this in and leave it the full resolution. So we'll hit OK, we'll hit continue. And we've got our points. So there's that 2.6 million points right now in our model. Now, if I hit Control A, we can see all those points that make up our project. And if I'm only interested in the information in here, well, I could draw something in. Now, I'm familiar with this file, but if I wasn't and I wanted a little more context for where things are at, and do it this time, we should have set the projection on import, but we can do it after the fact. So we could say, well, that's where my project extents are. Let's bring in an ortho image. We've got that ortho image. I won't download it in the full detail, but and sure, let's throw it in there. So now I've got an ortho image. It's a little easier to tell where I might want to be. I'm going to draw a feature. I'm going to call it AOI. And I'm going to say, well, I want everything within this polygon. And everything outside of it, I can make it, eliminate it altogether, or just make it really sparse. So for that, I'd go train modeling. I'd click simplify. Now I'll make it really sparse outside of that. I won't eliminate it altogether. So I'm going to say I don't want any more than 1 point per 30 meter rectangular cell. And I'm going to add an excluded region in here, and that's that feature that I've just drawn in that I've called AOI. So we'll hit OK, we'll hit OK. And, well, I can see down here I'm at less than 1 million. I could also hit Control A to see where those LiDAR points are, and I've got that full resolution in my area of interest, but outside of it, it's sparse. So we can run with that, continue on just the way that we've done it before. Model our surface. We can check out the surface there, and we can see that there's a pretty sudden transition from where we're full LiDAR resolution to the lower res data. But yeah, we've dramatically reduced the size of our file in doing so. So yeah, and that's kind of the long-winded response. The short response, yes, you can thin your data. You can use the simplify tool after import. You can simplify on import if you want. And then if you're dealing with DEM data, we could also run with the simplify smooth tool for that. Lots of functionality in there, pretty easy to work with, and pretty easy to keep your files nice and light, but we do have a high ceiling anyway.
Yeah. And again, entire webinar on working with large data sets that gives you a whole bunch of different tools and tips that is available. And perhaps in our follow-up note for this one, we can include a listing of some of those sort of key webinars. Okay, Matt, next question. Is it easy to adjust streams, the hydrology, in the software if we find that they're slightly different location in the field?
Oh, yeah, that's a good question. Let's see here. Let's run our hydrology tools. So I'm going to use it on the course data, or the one that we've just created. So there we've got our streams. Now there's different ways we could go about that. So if it was a case where I've run the tool and I'm noticing that there's a trend where my streams start too high in the watershed. So it might be that we've run the tool, and when we put boots on the ground, we're finding that maybe this stream actually starts down here rather than up here. Maybe this one starts here. Well, in that case, we probably have too small of a stream drainage area. So when this tool's working, it's looking at, well, if a drop of water fell here, goes down cell by cell. So this is a cell approximation of our tin, or a raster approximation of our tin. So it goes cell by cell until that drop of water reaches somewhere where the contributing flow area is greater than this value. And then once that threshold's hit, we start generating a stream. So if we make this, again, let's go a bigger number, we'll hit OK, and we'll see that, well, instead of starting up here, that's starting down here. And yeah, so that's one tool that we can use, and we can kind of calibrate it either based on field observations and even the first crack at it. You can probably run the tool, look at the topography data and see, okay, it's starting where there's probably no channel. Maybe we're a little too small with the number we're using there. Now, the other side of it could be that, and it's going to be more common in areas without defined channels and maybe poor surface quality data. So up here, I think we're kind of dealing with a swamp. And maybe it's a brushy swamp. Maybe the stream doesn't actually run through there. Maybe we've taken the time to GPS it, in which case we just bring in the GPS line and swap it out. But if it was just a field observation where I was there and said, well, actually it doesn't go from here all the way over to there, it kind of runs directly straight through, well, we could just edit the line. So we could move individual points. Now this has lots of points on it, so that would be a nuisance. And so instead we could say, well, I want to break this guy here. And if it were me doing it, I'd hit Control Q. But if we weren't familiar with the quick keys, we could come up here. We could break at current point. We could alternatively, instead of going to the ribbon, modify break at current point. So we've isolated the area that we don't want. And then we could just grab this guy here, that guy there, and Again, I'd hit Control-J just because I'm familiar with the quick keys. But we could go to the ribbon and hit join, or we could right click and hit join. So we've got two methods to tweak things. We could either manually move things around with our mouse and make adjustments. I guess we could also just insert the data if we had it, say, as a GPS data set or a file that has the streams already mapped. Or if we're kind of noticing that our settings may not have been appropriate when we originally ran the tool, we can iterate, tweak things, and this will be the primary tool to play with in order to influence where those streams start. So hopefully that's answers the question. It's, again, another one, as Aaron said, one of those things that, yeah, there's lots of functionality in the hydrology tools. There's also other hydrology tools that we haven't touched on here, so we can easily cover that in its own webinar topic.
Awesome. Okay, our last question of the day, and I think this is a really interesting one because it brings up a whole bunch of points. So the question is, what has happened to the survey map module? So we talked in this webinar about terrain and about location. Those are the two primary modules for RoadEng, especially now that LiDAR data has become, increasingly more common. We tend to talk a little bit less about survey map. So I'm going to introduce a couple concepts, then I'll pass it over to Matt and he can chat a little bit more in detail. But RoadEng comes, I'm going to say, essentially in two flavors. The first flavor is what we're going to call our RoadEng Forest Engineer or RoadEng Resource Engineer. And this version has a bunch of tools and functions very unique for forestry. And that includes the survey map module, as well as you might notice in Matt's install right now, he's got a ribbon tab called Cable Analysis, soon to be replaced with forestry tools. But these are some very specific items that most people outside of forestry don't really need to access, so we don't have them available in your install. If you are running a RoadEng civil engineer install, that tab is going to be gone. You're not going to see the survey map on your desktop, but essentially the software is the same, just a couple of nuances in terms of defaults and a ribbon tab. And with that, Matt, I feel like passing it to you with an actual screen showing might make a bit more sense.
All right, so yeah, survey module still exists. Here I don't have the icon showing, but if you do the resource install, it will appear. You can open it from terrain or location, but I've just clicked that open and we can see, well, it's still there, and we can click new traverse, we can add it in, and we could go through and we could define our topo surface using a P-line survey. But yeah, and this, of course, as Aaron said, still widely used in many locations and primarily in the forest industry. But with the availability of LiDAR data, it's becoming less and less used or less and less relied on as the primary topo source. But yeah, it's still as effective as it has ever been. It's just the a lot more use for the LiDAR data sets and other remote sensed data sets.
Okay, and with that, a casual, 23 minutes over time. I just want to say thank you, Matt, for taking us through the workflow today. Thank you to everyone who took the time to be here, attend the webinar, check it out. If you have any other questions, I know they often come up after the webinar has finished. There will be an email address that you can reach out to that includes your certificate if you attended here live, or contains the video link. So yeah, please do reach out, ask us questions, and thank you so much for being here. We look forward to seeing you all at another webinar again soon.
Thanks
Thanks,
everyone.
Matt.